Hello. In this video, I'm going to talk about my journey in making computers with breadboards. You can skip to this timestamp to listen to me answer the question of the video. But for now, I'm going to start all the way from the beginning to illustrate some context for the video. And let's begin. So to start off, let me talk a little bit about Ben Eater as an overview. You may or may not know Ben Eater, but he is someone on YouTube who has been dedicating time to teaching electrical/computer engineering topics. So most notably, he is known for his fundamentals of computer architecture and his comprehensive tutorials on building a simple computer from scratch using only TTL chips and basic breadboard components. And of course, this video is going to be discussing the things that I learned from that series. So some context. Before I begin explaining what I learned, I want to talk about my journey in discovering him and building my own breadboard CPU. Now, to start, before I began exploring the field of breadboard computing and whatnot, I knew nothing, absolutely nothing about computer engineering or breadboards, or really not a lot about computer science in general. So, I mean, I had some interests in computers, so in things technical. So, for example, building with Legos, playing video games, Minecraft, and I touched an Arduino once, and like followed along with someone to turn on the LEDs on and off, something like that. But other than that, I had no exposure to anything really with electronics of anything of that sort. And to start it all off, on this journey, I remember just vividly one day during school quarantine. So this is back in 2020, around that time when schools shut down and my school had to host the classes on Zoom. We called it Zoom school, but basically during Zoom school, I remember I was getting really bored during the classes because of course everything is online, and I lost interest pretty quickly. But I remember my friend asking me to play video games during this time. I just played the class in the background. Meanwhile, I remember we were playing CSGO during a class, and we played a match of that online shooter game. It isn't too relevant, but we were playing this game, and then when we got off, because of course I still had to switch meetings for the different classes. In between that time, I was just getting really bored with these classes, and of course, like when I was playing the game, I suddenly had a thought that just popped into my head, and the only way I can really describe it is similar to how J.K. Rowling initially came up with the idea of Harry Potter. I remember seeing at one point that she said that the idea just popped into her head, and it was a similar situation for me. I was playing video games one day, and I suddenly had the question of how do computers work? And this was really sudden. So at first, I want to point out that this seems like a pretty daunting question. But anyways, nowadays the internet is at our fingertips. So I quickly searched it up. How do computers work? And the typical answer popped up. So of course there's the idea of a CPU, and this CPU is like the brains of a computer, and it's connected to like memory, and then via the motherboard connected to monitors. Well, blah 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 blah. I don't want to get too technical, but basic results turned up and kind of answered my question. Oh, these are all the things that connect up to make a computer work, and I moved on with my day. But sometime later, I think it was the next day, I was once again bored in Zoom class, and I really wasn't satisfied with that answer. I mean, if you think about it, computers are pretty magical. They really are. So imagine describing to someone before the 20th century that you are able to make things move on a wall and play games, not only talk with someone from around the world, but also see them in real time. And you can also buy something from across the world and have it arrive in just days or even less. I mean, it sounds absolutely absurd if you think about it from that perspective. But I don't know. Maybe we're so used to it now, but I was just in that moment. I thought, if you were to drop me in the middle of a forest, so here's just a rough drawing of the imagery that I was thinking of. If you were to drop me in the middle of a forest, in the middle of nowhere, how would I be able to construct a computer from scratch? So I thought about this for long enough, and now it seems a little bit impossible, right? So how exactly are you supposed to gather natural resources and then turn it into a computer? And this really got me thinking. And as a curious person, I just needed more specific answers than what I got from simple internet search. And then this is where I kind of got some answers. Similar to that internet search, I just went one level deeper. And once I started really digging into that computer from scratch questions, I started off by watching online videos of computer history, because what better to start learning how computers work when people were actually trying to invent them. So just basic overviews. So I watched like crash course videos, which were super helpful. I enjoyed them a lot. They explain how the first computer was invented by Charles Babbage, and the first computer programmer was Ada Lovelace. And then it started discussing more technical topics such as transistors, logic gates, flip-flops, memory RAM, the ALU, CPU, etc. And the series went pretty fast, and I soon was wondering to myself, yeah, that's pretty cool. And I probably could have stopped there, but I just kept on thinking to myself over and over again that I still don't really know how to build a computer in the middle of the woods. And this is just some thought, some sort of imagery that I keep on going over throughout the video, because it's just the way that I thought if I wasn't going to stop until I figured out how to build a computer exactly from scratch. Okay, so I went on the internet, got a broad overview, and then I went a little bit deeper and got into some crash course videos and some history about computers. But this is where Ben Eater comes in. So, answers from Ben Eater. Just like most people, I first discovered Ben Eater through his 4-bit adder video. How do computers add numbers? I watched so many of these computer videos at this point of wondering how they worked. I mean, the YouTube algorithm had to show me some of his videos at some point. Well, anyways, I watched that video and I was immediately addicted. If you haven't watched this video, I don't know why you would be watching this video, but I would recommend stop watching my video right now and go watch Ben Eater's video on how computers add numbers, because watching it will do wonders for your understanding of the modern world. I mean, the execution was brilliant. The explanation was flawless. I remember the first time that I watched that 13-minute video, in the end, I not only understood the video question, how do computers add numbers, but I wanted to know more. So Ben was able to explain to me, someone who had no experience with circuits other than maybe like some previous videos that I watched and online searching, occasional phrase drops about circuits, in extremely simple terms. Ben was able to explain in extremely simple terms how you could use transistors to make logic gates, and then half adders, and then full adders, which are able to add numbers. I just couldn't believe how unbelievably simple the process was. Then, here was the big thing. He actually built the system. I mean, physically built the concept into the real world, and it worked. So I just recall thinking that this was a wow moment, that it was so simple and made so much sense to build a circuit that could add numbers, make computers add numbers, that got me thinking about how does other stuff work. So after watching that crash course video, this is like sort of like the ALU, arithmetic logic unit. So I knew how the computers add numbers, but a big thing was also memory, you know. So I searched up again on Beneder's channel, and this video popped up, the D flip-flop, and it basically explains how computers are able to remember bits. And after watching that video, I had the same feeling that Beneder's explanation was incredible, and I completely understood everything, and it made so much sense. It was genius. So I learned all these concepts, and most of all, I remembered that I wanted to build it, and I did. So here's my 4-bit adder, and I did post a video on YouTube of like a while after I built it, but that's not the point. I built it, and now we're finally getting into some of the topics of this video. But while browsing through his YouTube channel, I saw Beneder making videos of all these different concepts, seemingly complicated and disconnected ideas, and I made it all the way to the bottom and suddenly realized that these weren't all random things that he was posting on his channel. He was actually building a computer on breadboards, and that was another wow moment. And the rest is history. So I spent hours watching through every single one of them, at least a couple of times minimum, and thinking to myself that this was something that I wanted to do. I wanted to build Beneder's 8-bit computer. So I finally got the chance to build the SAP-1 in 2021 during a school winter break. And I got to order the kit from his website, and I spent nearly 10 hours a day during the week, and of course, days afterwards, working on that thing after school started up again. And I have to say that the effort was well worth it. I did decide to film time lapses of the process and upload also this channel if you want to check it out. But anyways, after I built the SAP-1, I felt really accomplished. And my initial question that first arrived over a year ago of building a computer from scratch with the help of Beneder was somewhat answered. I finally knew how a computer fundamentally worked at a machine code level, and I knew now what it means when the world is run on ones and zeros. There was still something missing though. After I built SAP-1, my quench for understanding was satisfied for a short while. You see, while I was building the SAP-1 and a little bit after, I quickly found numerous videos online of people much more experienced than me who had used what they learned to build enhanced versions of Beneder's dubbed SAP-1. They were managed to enhance their breadboard computers into much more complicated constructions. And that's when I knew that I just had to do more. You know, I was thinking to myself, why should I just stop there? So now I spent the next year researching the various components that could really level up the capabilities of the SAP-1. Now this was a really long process, but I'll just overview some ideas that I went over, such as memory mapping, I/O ports, stack pointers, bit shifting, blah, blah, blah. And I realized that I wanted to build an even grander contraption in my own custom computer. And I believe that this would be the final test to see if I really understood what I was doing. So I then spent hundreds of more hours constructing a new computer. and incorporating these new ideas that I was discovering into that computer. And then one day, I went on to next, and I just kept on building and building. And about a couple of months ago, I was in the middle of building my ALU when all of a sudden I got thinking to myself, hey, I've gone so far since the beginning. So I was just wondering, if I'm so interested in this topic, then there are probably other people out there that may have the same experience as me, who have the same interests but are unable to figure out how they could get started on such a project. But most importantly, I kind of questioned myself a little bit of what I learned. Yeah, I knew how 2 1s into an AND gate return a 1, and how all this technical stuff, how ALUs taking inputs, spit them back out onto a bus line, registers, memory, blah, blah, blah. I knew how all these technical things work, but really, what was the whole point of this? It definitely isn't so I could be airlifted out of town and dropped into Canadian wilderness or something. Although that does sound pretty cool. But really, why am I doing this? What's the end goal after I built the computer? And a really complex answer of what I learned, I really couldn't say. So I took some time off of the project and decided to compile some of my thoughts here into this video. So now that I've said all these things, I've been through a lot, for at least I can say, in terms of working with breadboard computers and learning about them online and building them myself. So let me highlight some things that I've learned throughout this journey. So number 1 is the fundamentals of learning new information. So the first thing, in other words, is learning how to learn by yourself, how to teach a topic to yourself. So I've self-studied topics in the past, but the topic of building computers from scratch is really nothing short of an entire semester of computer engineering in college. I mean, some people are learning these topics I've seen online for literally a year in college, and they go through all these different topics under the guidance of a professor or something or a textbook or whatever. And just saying that learning about the topics for building the SAP-1 was no small feat, even with Ben Eater's excellent explanations. I still had to learn how to figure out things that he was teaching effectively. So what I'm trying to say is, whether I'm searching for answers or discovering new ideas, building the breadboard computer taught me to try things really out for myself, aside from Ben Eater's explanations, and to just see what happens after I try something. So depending on what happens, or the aftermath of whatever I try, to guide my learning process. And in this act of continuously trying new things, you're going to fail a lot. You're going to fail a lot while trying new things. And this is one big thing with building a computer on breadboards. And Ben mentioned it in a video explaining this crucial aspect of why he was building a breadboard, or a computer on breadboard, because he does point out that there are kits on where you can build a computer out of PCBs, and you can solder the connections and everything. And you still learn how the computer works, but really for a breadboard, every single connection on the board takes several seconds of your time to connect and analyze it. And if that connection or something fails, or you accidentally mess up, the only way to fix it is if you completely understand the entire system. With building the computer with wires and everything on breadboards, failure is inevitable, like pretty much guaranteed. Sure, you can ask for help and people will give it to you online. Like, the community surrounding the project is incredible. But failure is just going to happen at some point, and there's no faking the understanding, no pretending that you know what you're doing. If you can't fix it, then either you don't understand enough, or you just need to keep on trying. Basically, once you solve it, you're not only rewarded with that constant, with that, the success of that fixed section. Once you've solved that failure, you found understanding from that mistake. And it kind of fits the model for learning and improving where you fail and just learning from your mistakes. You don't know when you succeed until you fail over and over and over again. Building the SAP-1 involves a lot of debugging, and debugging plays a massive role in the project. In fact, most of the time is spent debugging and trying to fix the mistakes that you've made along the way. Electronics is one of the hardest of all technical disciplines, and one mistake equals 0 results. So then again, once you finish the project, you've understood that project and you are able to use that knowledge to try to build something better, to demonstrate your understanding and to learn more about that field. Even now, I am still learning and hoping that these types of videos that I'm making will not only serve as resources for other people to learn, but also for me to learn as myself. So here's a quote that Einstein has said: "If you can't explain it to a 6-year-old, you don't understand it yourself." Learn from your mistakes. So another big part of Benioff's computer, so another big idea as you build Benioff's SAP-1 is the idea of breaking things down. So when I'm talking about breaking things down is taking a whole topic that may be daunting at first glance into smaller topics that will be more easy to understand, they're more digestible. So as you build SAP-1, the more you're going to realize the significance of this idea of breaking large concepts into tiny ones. And for myself, the more I explore the world, the more I realize that this concept of breaking things down is very universal and kind of the reverse way as well. If you take simple things and combine them together into a much bigger idea. And I thought of a really quick example for this, or a quick analogy for this idea. It could be a stone castle. So imagine you want to build a castle. You don't want to start learning how to build a castle just by taking a look at a castle, right? You might start off with getting a stone. So here we have a stone, a smaller piece of that castle, and building on top of that. So once you get the stone, you might want to build something like the foundation, and then building like maybe the first floor and then the second floor or whatever. And then you just keep on building on that singular concept of the stone, and you just keep adding more stones, and eventually you'll get a castle. So that's kind of what I mean. Something like that. What I'm trying to say is, if you don't understand or want to understand something, take that subject and just dissect it into many parts and understand those individual parts individually before you combine it into a whole. So for Ben's SAP-1, it's a pretty big project, and you can't just take it head on in one big swoop. So you must split it into different modules, and then you split those modules up even more subjects, and then they may not appear useful or interesting by themselves, but in the end you will be able to add them all up and it becomes one working whole. So you can think of the computer, and then maybe a really easy example could split it down into the clock module, and then inside the clock module you split it up into the 3 separate parts of the 555 timer, and then you just start working from there and understanding it from a really basic level, and learning all these different parts and then adding it up all together. And then you would be able to understand the entire thing. Okay, and here is another thing that I learned from building Ben Eater's SAP-1, and it's not really technical, but just for myself, is understanding the authenticity of computer science as a science. And what I'm trying to get at is that, just think about it this way. So it was just me realizing or questioning where this recent field of science has come in computer science and computer engineering, all those related topics. So when people think of science today, the answer is in some way probably some life science like biology, chemistry, physics, stuff like that, and maybe computer science, but biology, chemistry, physics, and those various topics have been pretty universal. So people have been studying them for thousands of years, utilizing tools from the natural world. And compared to these traditional sciences, computer science is only at most maybe 200 years old, with most advances from the past 60 to 70 years. So when I think of computer science, I think of maybe coding, making websites, the internet. But here's a pretty extreme take. But how is writing print world like a part of computer science? And you might have to think this about for a while. But for me, when I think about computer science, the first thing I think about is like, oh, and when you're coding, the first thing that you write in coding is hello world. And I'm thinking about how is writing print world qualified enough to be categorized under term as professional as computer science. I mean, is this even science? Because when you come to like other sciences like biology or physics, they all have these really complex topics, and then that you have to understand, you have to take like days to understand. They're not too easy to hard, like there's formulas and all these abstractions that you have to think of, like in biology, all these complex life science stuff. Well, basically all these complex things. And then in computer science, you can just write print hello world, and you can just say, oh, I've coded before, I've done computer science, blah blah blah, yada yada yada. But how is this really considered hello world a computer science? Like, is it even science? Now that was pretty extreme, but through the SAP-1, I have more realized that authenticity of computer science. I've realized that humankind has only recently developed the tools for efficient automation, which makes the field of computer science even possible. And that goal of computer science is to explore what is possible with automation, using computers to do the tasks that us humans tell them to do. So this involves exploring the possibilities of utilizing electronics to perform unfathomable tasks that would have been impossible hundreds of years ago. For example, like some of the crazy stuff that would be unthinkable to someone from the past, like the internet, self-driving cars, like machine learning, other crazy stuff. We've, as humans, have just taken this chunk of rock and really leveled it up, like controlling spaceships, all this crazy stuff. And it really has only emerged with the advent of computers, which have been only really invented in the last couple of decades. And working on SAP-1 and subsequent research on other topics related to it, understanding computer architecture, learning how computers work, has just really strengthened my perspective on computer science as a whole and understanding what it is all about to be studying in this field. And so, of course, another thing that I want to discuss pretty briefly is that, of course, in Ben Eater's 8-bit CPU, I did learn how computers work. And then this is just to connect really some of the topics from before. For hardware, you really get a big idea overview of how computers work, from like hardware level, transistors to logic gates to circuits, and then to computer. So you really understand the importance of the instruction cycle in executing instructions. Electronics, basic electronic stuff, microcontrollers. You get to work with an Arduino and coding in Arduino and software, and basic computer science topics such as conditionals and loops. And those are just some things that you'll learn from the series. And of course, that's pretty obvious, and I don't want to get too deep into that. And lastly, as a beginner, I found a lot of what I guess are tips and tricks over time from working with breadboard computers that I would like to think would be useful to beginners if I were to share these things. So, for example, these are just a couple of things that I've thought of. So, where to buy stuff, that's something that people have trouble with. And then, like, maybe a setup for working, like a working environment, how to set up a working environment to build a computer. And then, of course, I've been thinking a lot about discussing some cool stuff or topics that I found online that maybe were confusing to me at first, that I might want to explain them in my own terms for other people to understand for themselves. Even if the information is out there, it's just another resource if I were to make a video or something to explain the information. Just something that I either found useful or would like to share to the world. So I do have more plans for my breadboard computing journey. I've spent pretty much the last year designing and building my own custom computer, as I've discussed. So basically from that process, it's the idea that I understand the basics, and I really want to see where I can step it up a notch from that point. As of filming this, I've already worked out the details for that enhanced 8-bit computer, still working out some extra ideas here and there. But as mentioned in the video that I made earlier this year, I will continue building and working on it. And I'm also planning on uploading some videos about my progress on that endeavor. And it's also always great to learn from others' mistakes. So I also be, as I said, from the tips and tricks from this process, discussing videos on my channel about various other topics of how I probably maybe did things and best practices, etc., etc. And I hope to explain these concepts that I found difficult to grasp from my standpoint, from when I was first figuring everything out. So as a complete novice. So that's pretty much it. Computers have fundamentally altered humanity in the last several decades. Ever since I first watched Ben Eater's video, it has pretty much changed my life in how I see computers. And shortly after I watched that video, I got really into coding, programming, and stuff like that, like computer science topics like game development, web development, etc., etc. But I don't want to drone on for any much longer. This video has already been long enough. But anyways, I hope that made sense. I hope this video was informational, or at least help at least one person in some way. If you have any questions, please leave them in the comments below. And yeah, that's pretty much it. Hope you have a great day. See ya.